Okay, so in this video, we're going to look at how to determine transformations. So in a couple other videos, we've looked at how to map or use matrices to apply transformations to a graph. In this one, we're looking at how you can describe the transformations or determine the transformations that were used to come up with that graph. So we've got 3 steps. The first thing is we need to work out which of the equations is the image. And that's always going to be the one where it has become this or gone to this, transformed from this to this. Okay, we're going to put x dash and y dash in there straight away. Once you've done that, you're then going to get your equations and move all the transformations to do with the x value on one side of the equation and the y value the one side of the equation. We'll see it in a minute. And once you've done that, you equate them and solve for x dash and y dash. Then you list your transformations based on BODMAS using generally the description of DRT. Dr. T, dilations, reflections, then translations for the x values and for the y values. So let's see how it works. Determine the set of transformations that would map y equals that to y equals x cubed. Well, we first of all have to decide which is the image. Now the image in this case is this one here. That's the image. So I'm going to write y dash equals x dash cubed. That's what I'm going to think. Okay, that's my image. And over this other one now, I want to get all the transformations that affect my y value over to join the y. Now, the ones that affect that are the -2, because that's a vertical translation, and the 3, that's a dilation from the x-axis. So those two are going to move across, and we have to use BODMAS. So you're going to have y plus 2, and then I'm going to divide by 3. And that gives me x minus 1 cubed. Now, all the transformations that affect the x value are still sitting here, and that is going to be inside this bracket here. Pretty much always going to be inside that bracket. Not every single time, but very, very small handful of times it won't be. And that's just this -1. So we've determined our image. We've got all the y things on one side, x things on the other side. Now I can put them equal to each other. So therefore, I say that y dash, this y dash here, is equivalent to y plus 2 over 3. And this x dash is equal to x minus 1. Now, in the instructions above, I said you need to get x dash and y dash by themselves. Notice they already are. So it means you can actually read what's happening to the original function to get back to the, or get across to the image. So what would have mapped y equals 3, x minus 1 cubed minus 2 to this thing? Well, we think, hang on, I had to add 2 to get, there's no -2 there, so that 2 has been added, and I must have divided by 3 at some stage because that's gone too. All right, so you can see they're gone. But when we describe it, we like to describe them in terms of dilations, reflections, translations. So to do that accurately, you need to write 1/3 y plus 2/3, and because you always describe in BODMAS. If I'm using this one, BODMAS says that the plus 2 comes first. So I describe the translation of 2 up, then you'd have a dilation factor of 1/3. But if you're trying to do it following the DRT method, you need to write it as 2 separate fractions. So now I can see, therefore, we are using dilations first. We have a dilation of factor 1/3. That's clear there. And that is from the x-axis because it's multiplying the y value. Remember, multiplying the y value moves it up or down depending on how big you're multiplying it by. And that's followed by, so you've done that first, followed by a translation of 2/3 up vertical translation of 2/3 up. Then, well, that's all these ones done. They're done. The only transformation left now is this -1. Now, if you have x and you've taken away 1, that means you've moved it to the left 1. So then a horizontal translation of 1 unit left. And that's it. You could do it in list form. You could do dilation of 1/3, then vertical translation, then horizontal translation. The horizontal translation and the vertical translation doesn't matter the order. We've done dilations first, and then we've done translations. Let's continue on to the next one. Y equals 2 sine of pi x plus 2 minus 1 going across 2 sine of x. Again, which one is the image? Well, this second one is going to be the image because we're going to that one. So that means that y dash equals sine of x dash, like that. With that in mind, I now need to get all the y transformations on this side across to join the y. So I add 1 across and then I divide by 2, and that's going to give me sine of pi x plus 2. Now the pi and the 2 have to stay in with the x. That's actually to do with the x value. All the y value stuff is on the left hand side, x value on the right hand side. We now equate. So I'm going to put y dash equal to the y plus 1 over 2. That's the left hand side there, and they can go equal to each other. And again, I'm going to separate it out as 1/2 y plus 1/2, so I can describe with dilations first. Remember, if you left it as a fraction like this one, the translation has to be written first. Now, x dash is everything inside the sine function. Well, everything inside the sine function is pi x plus 2, and there's no transposing needed here, no separating because you haven't got a fraction. It's just 2 symbols as it is. So now what we do is list our transformations. So we have dilation of factor 1/2 from the x-axis, and that's because we've divided it by 2. We're trying to get rid of this 2. So go 2 to there, we have to divide by the 2. Dilation of factor 1/2 from the x-axis, we've had dilation of factor pi from the y-axis. Now it's from the y-axis because it's affecting the x value. Now it's dilation of factor pi because remember this thing here is 1 over pi is your dilation factor in there. Remember, it's always 1 over whatever that value is. So 1 over pi is your dilation factor. So to undo 1 over pi, it's a dilation factor pi that undoes it. Then we have a vertical translation of 1/2 unit down. Because we divided by 2 first, that disappeared and you got a half. That's why it's 1/2. Oh, not down, it's up, sorry. 1/2 up, I should say. And then a horizontal translation. Don't know why I wrote the whole thing. Of 2 units right. And there are 4 transformations. 1 dilation there, 1 there, translation, translation. And let's look at our last one. So we got 1 on x becoming y equals, I should actually put a reflection there somewhere, so I'm going to chuck a reflection there so we can see it coming out. So y equals 1 over x becomes y equals -2 over x plus 3 minus 1. So this thing is what it's becoming. So that there is the image. So we're going to have y dash equals -2 over x dash plus 3 minus 1. Okay, in this case, our y and our x are already by themselves. We've already got y equals and x equals and no other transformations happening. So this time we have to look at this one over here. So we know y dash. We want to get everything affects our y dash on one side. So we know y dash is affected by this -1. So we've got to add 1 across. And we want a 1 in the numerator. We have a -2. So the way we do that is by dividing by -2. Like that. And that will equal 1 over x dash plus 3. Once we've done that, notice everything that affects a y value is there, and everything that affects an x value is there. At this point, we now can say y equals y dash plus 1 over -2, and x equals x dash plus 3. Notice I'm not doing 1 over x. The general format of the function is 1 over x, but we're just looking where the x is located, which is in the denominator. So we're going to equate the two denominators to each other, x plus 3 and the x. Once we have that, our job is to get x dash and y dash by themselves. X dash is easy, we just subtract 3 and we get that. To get y dash, it's a little bit more work, not too bad. We multiply by -2 and then we subtract by 1. There's no fraction involved in this case, so we can see easily what all the transformations are. We've got a -2 there, so it's a dilation and a reflection. And then we have a 1 and a -3, which are both translations. So to list them all off, we start with dilation of factor 2. It's affecting the y value, so it's from the x-axis. Then we have a reflection it's affecting the y value, so it's around the x-axis. Then we have a vertical translation, so translation of 1 unit, and it's going up. And then we have, hang on, yeah, sorry. I should have subtracted that 1 right there, not added that 1. Sorry for those who are wondering why I did that through the video. The 1 down, and then a horizontal translation of 3 units left, because x minus 3 units left. And my minor algebraic error aside, that is how you determine transformations in functions.